This nested loop solution works. But once the data set grows, this approach becomes a serious performance problem. The repeated scanning is actually the problem. Let's solve the same problem first with brute force, then we optimize it with sliding window. The task is to find the longest continuous subarray without repeating numbers. In this example, the answer is 4 because the longest valid subarray is 3, 2, 4, 5. The brute force idea is simple. We try every possible starting position. From each starting position, we expand forward until we find a duplicate. Now, once a duplicate appears, this current subarray is no longer valid. We continuously scan or track the largest valid subarray found so far. This works correctly, but we repeatedly scan the same elements again and again. That repeated work is what makes this approach expensive. Let's first test the brute force solution. So the result is correct, but correctness alone is not enough. In interviews and real systems, we also care about scalability. Let's implement the sliding window. Instead of restarting every scan, we maintain a moving window. The window is now at 1. The left and right pointers define the current window. This window is now 1, 2, 3. As long as there is no duplicate, the right pointer keeps expanding the window. Duplicate is now 2. Now we found another 2. So the current window is no longer valid. Our new valid window is now 3, 2. We move left after the previous 2. So the window becomes valid again. Math.max is important because we don't never want the left pointer moving backward. The hash map helps us instantly know where each number was last seen. So this helps us to instantly know where each number was last seen. Our longest valid window now is 3, 2, 4, 5. 3, 2, 4, 5 in this window. Now every number is processed at most once. We eliminated repeated scanning completely. Now let's run the optimized sliding window solution. Same result, but very different performance. The brute force solution can become O(n squared) because for every starting position, we may scan forward again. The sliding window solution is O(n) because each number is processed as the right pointer moves through the array. The sliding window solution avoids repeated scanning completely. The art of interview preparation focuses only on correctness, but strong engineers also think about scalability, repeated work, and growth rate. When you see repeated scanning, ask if a sliding window or hash map can remove that repeated work. In the next video, we will generate large random datasets and compare both solutions more practically.